Thank you, Paul. Yesterday, some of you maybe saw where I reported out on the progress of the perch objective for Lake Huron, but a number of people have requested a presentation specific to Saginaw Bay at this meeting, partly because we're right here at the sort of the epicenter of the watershed and the fishery, thinking that that would be of interest to the audience. And it's timely in that we have also been developing a new recreational fisheries management plan. So it's sort of an opportunity to report out on the assessment and then to frame it in the context of management. Jeff Jolly, my co-author, is unable to be here today, so I'll kind of be covering both topics. We have a variety of information sources to inform decision making on Saginaw Bay. We have a fish community netting survey that has a gill netting and trawling component. The trawling dates all the way back to 1971 and the gill netting to 1989. So that's a fishery independent survey that gives us a lot of information on the overall status of walleye and perch, but other species as well. We have a jaw tagging project for walleye that gives us estimates of mortality rate, exploitation. We can even derive a population estimate from that, and it gives us some information about movement. Of course, there's a creel survey that takes place every year, almost year-round. It gives us estimates of harvest rate, and effort. And then there's commercial reporting. There's, of course, a state-licensed commercial fishery in Saginaw Bay, and those reporting are an additional source of information. And then we have various computer models that will allow us to further estimate what the mortality rates are of the walleye population, as well as a stochastic simulation model that we can sort of game through different sort of management scenarios. And all these together collectively sort of are the basis for us to understand the dynamics between walleye and yellow perch. This is creel survey information. These are harvest rates of walleye on the left y-axis and yellow perch on the right y-axis. And you can sort of see how they have always been divergent, especially when walleye harvest rate increased by 433% after 2003. That's when alewives became basically absent from Saginaw Bay and most of Lake Huron. As we start to think about management and what would be reasonable goals and objectives going forward, we thought a lot about this, and that there are many examples around North America of how abundant walleye populations seem to be incompatible with abundant yellow perch, or that they will suppress perch. But as we looked back over the history of Saginaw Bay in terms of, now this is yield from all sources, mostly that was commercial yield back in the late 1800s through the middle of the 20th century. We're real mindful of this period here where walleye and yellow perch were both abundant, and that was in a fairly pristine condition back in Saginaw Bay. So it is possible to have both abundant walleye and yellow perch, and we felt it really important to craft goals and objectives that reflect that ideal, and that we didn't want to give up on one in favor of the other. This is sort of an approximate timeline of management efforts in Saginaw Bay up through from the 1800s through the middle part of the 20th century. It was principally a commercial fishery. There's really little or no management that took place back then. Of course, a lot of the Great Lakes fisheries collapsed right around that point in the middle part of the 20th century up through the 1970s. The fisheries were greatly depressed or closed. Then things began to turn around in the 70s and 80s with improving water quality and water quality legislation and the advent of small fingerling stocking for walleye. Through the 80s up through 2003, there was a recreational fishery for walleye, but it was really stocking dependent. And there was a recovery plan that was developed, but the real key to that was the collapse of alewives in 2003. So in 2009, walleye reached their recovery targets, but yet yellow perch were greatly depressed. The Michigan Department of Natural Resources embarked on a management strategy of liberalized harvest regulations for walleye. Sort of an experiment to see that if walleye could be reduced through harvest, what benefit that may have on yellow perch. It really wasn't realized in terms of benefits for perch because as there was some reduction in the walleye numbers, the population pushed back with greater and larger year classes, so it never really got any smaller. And so now here we are today in 2024 with a new draft recreational management plan where the emphasis is shifting really onto sustainability and quality of the walleye recreational fishery and maintaining perch to be ready someday for recovery when conditions change. So this plan is draft and it's already been rolled out to some of our advisors. I thought by today it might be available publicly. It's not just yet, but it will be soon available for public comment. But what I wanted to try to do is to frame for you how this plan builds on the assessment that we're doing is sort of a foundation to help point to when decisions may have to be made. There's a whole presentation behind this that we don't have time for today in terms of the goals and vision statements, but I really want to try to frame this dashboard, and there's one for walleye and one for yellow perch. I realize that's hard to read, but there's categories on the left of sustainability, recruitment, quality, and they're balanced against a sort of objective function of recreational harvest. So you want to sort of maximize harvest, but stay within these different metrics, these ranges of reference points. And then there's different weights assigned to each of these. So some of these are more important than others. And then there's a different signal, sort of a green condition where things are at or above where we want them to be, or a yellow condition where there's some concern, some degree of risk, and then a red condition where things are in a condition or a state that is really concerning in terms of what the relative objectives are. And then each year we can calculate a score. So there's a total possible like 63 points for walleye, for example. So depending on where they are at based on our assessment, that then is multiplied times that weight and then times a multiplier for each signal. So like a 1 for green, 0.5 for yellow, 0 for red. And so in this case, the bigger the score, the better or the healthier the population is. And the whole idea is that no one metric is going to trigger a lot of decision making, rather it's going to be sort of a collective reflection of all these different metrics and priorities. So this is trends in age 0. So this is fall young of year walleye in the trawling, and you can see the big jump there in 2003. That's when alewives became scarce, or basically disappeared from most of Lake Huron. Of course, we've known for a long time that alewives are a formidable predator and competitor on newly hatched walleye and perch fry. So released from that, reproductive success really soared. Those percentages is hatchery contribution, which we know from oxytetracycline marking that was taking place. Stocking was discontinued in 2006, so that's why it's all zeros ever since. Really interesting to see sort of this period of like 3 stronger cohorts and then a weaker one, 3 stronger, then a weaker one. We think that that's reflective of certain density dynamics that are driving stock recruitment functions that are driving production, and then some compensation. So these are the green and the yellow and the area of red concern that have been identified in this draft plan. And so the sort of feedback we're going to be looking for ultimately is certainly the goals and objectives and strategies in the plan, but even do we have these right thresholds or reference points identified? And you can see where we are most recently in 2023. This is growth rate of walleye using age 3 sexes combined. And growth rate's important for a lot of reasons, obviously, but in this case, we were really using sort of a surrogate for telling us what the density of walleye were relative to the prey base and habitat. So if you look on that sort of that right y-axis, you can see that there's less walleyes if the growth rate's fast and higher up. There's more walleyes, really more specifically the walleye to prey ratio if growth rate is slower. So it's density dependent growth. And you can see how growth rate came down. We had a target there, and that was a criteria for declaring recovery was first met in 2009. So growth rate is actually a really useful metric in that we're letting the fish tell us where they are relative to the available prey base and habitat. And then these are the criteria for scoring, and the green zone is actually in the middle in this case because we don't want a faster growth rate in this case because that would indicate a lower walleye to prey ratio. This is a targeted harvest rate of walleye in Saginaw Bay as estimated by our creel survey. And the 0.4 has been the reference point that was identified. Lake Erie uses this same criteria, and we sort of adopted it. It's now in this draft plan. And so it looks like that in terms of where we are in terms of a quality measurement, if you will, of what the recreational fishery is achieving for walleye. This is harvest of walleye in the recreational fishery, split up between the open water fishery, the winter fishery, and then our charter fishery reports separately, so that's actually tacked on in a different color. And we've had a 313% increase in the harvest, reflecting the expansion of that population since 2003, and you can see where the most recent value is. And then the management plan calls for a harvest, or really specifically a population capable of that harvest in these ranges. This is alewife density in Lake Huron as estimated by the USGS bottom trawling survey. And the reason this is in a walleye and perch management plan is for those same reasons I described, because it's such a strong determinant in reproductive success of perkins that it's really the only way we can achieve and maintain walleye recovery, we believe, is if alewives remain scarce in Lake Huron. If they were to mount a recovery, we would likely lose our reproductive success with obvious consequences. And so this is actually one of our criteria, and as you can see, there's very little margin there. And this is based off of our stochastic simulation modeling that anything much more than about, I think, 0.25, what's the axis, alewives per hectare will begin to interrupt and interfere with walleye reproductive success. This is a forage index based on our trawling that's done every year. So it's sort of a collective of these different species that you see, kilograms per 10-minute tow. And that downward slide was really part of the concern that motivated the liberalization of harvest regulations for walleye that was implemented in 2015. Now we can see that it has rebounded some, although sometimes that's really being driven by just maybe one particular prey fish species that is particularly abundant that year. And these are the defined ranges. We have actual population estimates of walleye because of our statistical catch at age model, and it is currently about 10.2 million age 2 and older walleye. The dashed lines are two standard errors of the estimates of a confidence interval. And while this is reflective of a lot of different dynamics, recruitment and also mortality rates, it proves to be a useful metric overall for gauging where things are at, and these have been the identified thresholds. So here's that those same scores expressed on sort of a yearly trend, and we can do that calculation to determine what the collective score is and then plot that out. And in this case, the most recent is on the far left of this bottom graphic, and we can see that in our last year of full scoring, it's 55 out of 63 points possible. So obviously walleye are in very good condition and shape in Saginaw Bay. But let's take a look at yellow perch. This has been the trend in angler catch per unit effort. This is year round. You can see how it's trended down to a very low level and in the recreational fishery, and it's in that red zone. So in an unacceptable condition. If you look back at where things were as recently as late 80s and early 90s, you can see that it was much better. This is the recreational harvest. So this is numbers of fish being harvested of yellow perch, and you can see that it's, I think it's like 80,000 or something compared to some years back when it was in the millions. So obviously that's in an undesirable condition there. This is the commercial yield of walleye. So this is on the y-axis there is pounds, and you can see how it has trended as well. And although this is a recreational plan, the commercial yield is a useful indicator, one more look from a different fishery in terms of what that population is doing. And you can see that it too is in the red zone. So really the commercial fishery and the recreational fishery are both trended in the same way, suffering from the same issues. This is growth rate of age 3 yellow perch in Saginaw Bay. Just like with the walleye, growth rate being density dependent, this has been useful to look at. It is sort of a validation that everything else we think we're seeing in terms of the yellow perch population and fishery being depressed, yeah, the fish are telling us that as well because their growth rates are so fast, meaning there's very little intra-specific competition amongst themselves. And that's clearly in the red zone. Although it's a silver lining in some respects in that the few perch we do have out there are growing very fast. This is more trawling information. Yellow perch, age 0 and age 1. So the age 0 is the yellow bar, age 1 and older is the purple bar. You can see for a long time we had both, as you would expect. Nowadays we have a lot of yellow bar. That means a lot of young of year. So they're reproducing just fine, but we're not seeing them survive to the yearling and older sizes, which is what we need, of course, in terms of recruitment to both the recreational and the commercial fisheries. So this is really attributed to heavy predation rates from walleye, but other predators as well. And this is really the origin of the problem. We've identified these particular thresholds. This next slide actually quantifies that mortality rate between age 0 and age 1 by year. And you can see that mortality rate some years is as high as 99%. And these are the criteria identified for that particular perch metric. So here's the same sort of a dashboard and yearly assessment for yellow perch, and the y-axis down there on the bottom, you can see the most recent is on the left of that x-axis, and sadly yellow perch are at a 0 right now. So there's a lot more work to be done in terms of yellow perch recovery, and there's a lot more strategies and efforts behind that I don't have time to go into today, but this is really the essence of our assessment framed in the context of this new draft management plan. And many people have contributed to not only that plan, but this presentation. And I'll have questions if there's time.